Students, today is the lecture 10 in which we are going to do the review exercise. In question number 1, we are given with some sequences and we have to tell the next two terms. In the part A, the sequence is 98, 89, 80, 71, 62. If you see this sequence, then you can easily observe that 9 is subtracted from each of the term to give the next term. This means that 9 will be subtracted from 62 to give the next term, and 9 will be subtracted from the next term to give the next term. So the next two terms are 53 and 44. In the B part, the sequence is -2, 0, 4, 10, 18 up to so on. You can easily see that even numbers are added in each of the term to get the next term. So if the last term is 18 and 8 is added in the previous term to get this term, this means that 10 will be added in 18 to give the next term, which will be 28, and 12 will be added in 28 to give the next term, which will be 40. In the C part, the sequence is 9, 3, 1, 1 by 3, 1 by 9. In this sequence, 3 is divided to each term to give the next term. This means that when we will divide 1 by 9 with the 3, so it will become 1 by 27, and 1 by 27 is divided by 3 to give the next term, which is 1 by 81. In the D part, 1, 9, 25, 49, 81. In this sequence, we observe that these are the squares of all the odd numbers. 1 is the square of 1, 9 is the square of 3, 25 is the square of 5, 49 is the square of 7, and 81 is the square of 9. So this means that the next term will be 11. The square of 11 is 121, and the square of 13 is 169. So the next two terms will be 121 and 169. Okay. Now question number 2. Question number 2, and the sequence in question number 2 is 9, 16, 25, 36, 49. You can observe that these are the squares of the of some numbers. That is 3 is the square, 9 is the square of 3, 16 is the square of 4, 25 is the square of 5, 36 is the square of 6, and 49 is the square of 7. So we have to write the next two terms of the sequence. This means that the next term will be the square of 8, and the square of 8 is 64. Similarly, the square of 9 is 81. The next part of question number 1 states that find the formula for the nth term of the sequence. As you can see here, the terms were started from 3. This means that 2 terms are missing, so we will add that 2 in the nth term to give the formula. So the general term of the sequence will be Tn is equals to n plus 2 whole square. The third part states that hence find the 25th term. So we will substitute 25 in the place of n to give the 25th term. So 25 plus 2 is equals to 27, and the answer is 729. Question number 3. Kate used the buttons to make the sequences. We have to draw the fifth figure. If you see the figures in your book, the figure 4 has 4 button lines in the column and 1 button line in the row. This means that in the fifth figure there will be 5 button lines in a column and 1 button line in a row. In the second part, we have to complete the table. In this table, this 5 represents these 5 buttons. This 5 represents these 5 buttons. 1 represents this column line, and this one represents this button. In the second figure, you can easily observe that there are 2 column lines, therefore 2 is written here. In the third figure, there are 3 button lines. In the fourth figure, there are 4 button lines, and up to so on. Okay, in this way we can write that the figure number 5 is 5. This is the this 5 buttons which will remain constant, and the number which is changing is the button line in the column, that is 5, and plus 1 represents this button. So after the simplifications, we will get that the answer is 26, and by so on we can get a general form which will be 5n plus 1. In the part 3, find the number of the buttons in the 56 figure. This means that 56 will be replaced in the place of n. So 5 multiplied by 56 plus 1, the answer is 281. In the fourth part, is it possible for a figure in the sequence to be made up of 583 buttons? Okay, so here we are given with the buttons, and we have to use the general formula to find out the figure. Okay, so we are given with the formula 5n plus 1 is equals to 583. This one will go to the right hand side and will be subtracted from this term. So 583 minus 1, the answer is 582 divided by 5. We get the answer in the decimal form, 116.4, I guess. So this does not belongs to the positive integers as the value is in decimal. So we will write that it is not possible for a figure in the sequence to be made up of 583 buttons. Question number 4. In question number 4, we are given with some patterns with some figures, and we have to draw the next figure. Okay, in the first term, in the first figure we have only one triangle. In the second figure we have two triangle, one mini triangle and one bigger triangle. This means that one triangle is added in each of the figures. So if we have to find the figure number 5, this means that in figure number 5 we will have 5 triangles. So we will count here 1 2 3 4 5. So in figure number 5 we have 5 mini triangles in a bigger triangle. Okay, part 2 है complete the table. We are given with the figure numbers, and we have to tell the number of the triangles according to their figure numbers, as 4 terms are mentioned in the book. So by seeing these numbers we can easily tell that the 1 2 3 4, the next term will be 5, 2 3 4 5 6 5, and the next term will be 6, and the division by the 2 is constant, so it will remain here like this. Okay, so if we consider this 1 by 2, so we will write 1 by 2 here. 1 2 3 4 5, this represents the value of the n, and as you can see that this value was started from 2, so the 1 before this will be added to the n, so n plus 1. So this is our general formula to find out any term of the sequence. In the third part we are required to find the number of the triangles in the 77th figure. So we will replace 77th in the term in the place of n, as n is equals to 77. So after simplification we will get this answer 3003. In the fourth part, find the value of n for which the figure has 66 triangles. So as we are given with the triangles and we have to tell the figure number, so we will use the general term formula here. We will write that 66 is equals to 1 by 2 n plus 1, as 2 is in the denominator on the left hand side, it will go to the right hand side and multiply with 66, and after simplification we will get that 132 is equals to n plus 1. We have factorized 132 here, as 132 is obtained by multiplying 11 with 12, and by taking 11 as common we get 11 multiplied by 11 plus 1. By comparing this term with n plus 1, we can easily observe that n is equals to 11. Question number 5. We have a pattern, or you can say a sequence here, 1 cube, and in the second line we have 1 cube plus 2 cube is equals to 9, 1 plus 2 square. In the third line, 1 cube plus 3 cube plus 2 cube is equals to 36 is equals to 1 plus 2 plus 3 square. This means that if this is a 4 line, then the numbers will be added till 4. In the first part we have to write the 7th line. If we have to find the 7th line, this means that the terms will be added till 7, and by solving it with the help of the calculator we can easily calculate that the answer of this sum is 784, and when the 1 plus 2 this is added till 7, and when we take the square we will get this answer. Okay, in the part B we have to find the value of 1 cube plus 2 cube plus 3 cube plus up to so on 15 cube. So we can do it with the help of the calculator. We will add these terms and then take the square to get this answer. In the third part we have to find the value of the k, as we know that the sequences are added till k, and and that value is equals to 1296. This value is given in our question. Okay, and by using the calculator we can see that this is the square of 36. now we will see that कि हम किन टर्म्स तक इसको ऐड करेंगे कि हमारे पास आंसर 36 आए. ओके, जब हमारे पास आंसर 36 आएगा इसका मतलब ये होगा कि हमने उस टर्म पे जाके स्टॉप कर देना है. ओके, सो वी एडेड द टर्म्स टिल 8. This means that 8 is our last term and 8 is the value of the k. Now moving toward our last question, question number 6, we are given with a table. Okay, and in the first part they tell us to find the value of the a. Okay, we are given with some sequences and some terms. The values of the c are 5, 10, 17, 26 a, and the value of the c we obtain the value of the c by adding the squares of these two terms and then taking the square root. As a we had to find the value of the a, so we took the square of 12 and then add the square of 35 in it. 12 square plus 35 square, the answer we have our answer 1369, and then we take the square root and get the answer 37. In the second part we had to find the formula for the nth term of the sequence a. So to find the formula we have the first step to find out the common difference, as we have to find the formula for the nth term of sequence a. So we see that the common difference, what is the common difference of the sequence a? Since 2 is added in 4 to get 6, 2 is added in 6 to get 8, and 2 is added in 8 to get 10. This means that the common difference of each term is 2. So we have write that the common difference of the sequence a is 2. Our next step is to find out the value of the constant. We find out the value of constant by subtracting the term 1 and the term naught. T1 minus T naught, as the first term is 4 and T naught represents the common difference, so 4 minus 2 is equals to 2. This means that the general formula have become Tn is equals to 2n plus 2. Now the third part states that if the nth term of the sequence b is n square plus 2, and find the 18th term of the sequence c. For this we have to firstly find the general term of the sequence c. As in the part 1 we had find out that the value of the sequence c is obtained by adding the squares of the sequence a and sequence b and then taking the square root. So the general formula will be adding the terms of the sequence a plus adding the terms of the sequence b. Now the general formula for the sequence a is 2n plus 2. We have found out this term, so we will substitute this here. Similarly for the b we can also find out the formula, that is n square plus 2n whole square. So when n is equals to 18, we will substitute 18 in the place of n, and after simplification we will get the answer 362.